Right, so now we're going to look at some chemical properties of our halogens, which are group 17. So halogens exist as a diatomic. So you have F2, Cl2, Br2, and I2. They're 4 of our 7 diatomics. For their physical properties, they are all colored, so you have to know these colors. So chlorine is a greenish colored gas. Sometimes people will even say that it's yellow. Bromine is a brownish color, dark red color. It forms a brown or dark red vapor. And iodine is actually violet in color. They show a gradual change from being a gas as fluorine and then going down to a liquid at bromine and a solid at iodine. For chemical properties, they're very reactive nonmetals, and reactivity decreases as you're going down because the atom is getting larger, so there's more shielding and the nucleus has to work harder to attract those electrons. They form ionic compounds with metals. They form covalent compounds with other nonmetals. Now, when we talk about them reacting with the alkali metals, they form what we call ionic halides. And an ionic halide is simply that metallic, the alkali metal and then the halogen. So you have group 1 metal, and you have group 17 element. The alkali metal will lose 1 electron and give it to the halogen. The halide will then gain that electron. So it's a 1-to-1 ratio. The electrostatic force of attraction is between the oppositely charged ions, so that electrostatic force of attraction is what's holding that unit together and making up their crystalline solid. The most vigorous reactions occur with elements that are the furthest apart. So the most vigorous then would be francium and fluorine reacting together. If we wanted to write that reaction, we would have francium plus fluorine to give us francium fluoride, and then we would need to balance it like that. All right, halogens and displacement reactions. This is when you switch partners. Single replacement is how we described it last year. Since the reactivity decreases down the group, the activity series of the halogens is the same as the order on the periodic table. So fluorine is the most reactive and then iodine is the least reactive. So fluorine will replace all other halogens. Iodine cannot replace any of the halogens. So if we look at some examples here, we have potassium bromide and then chlorine. So chlorine, being higher on the periodic table than bromine, will replace the bromine. So it's kind of like you're switching partners. And so we would have potassium chloride, cross your charges. And then bromine is a diatomic, so it would need that subscript 2. And then to balance it, we would put 2 and 2. All right, here we have bromine, potassium bromide, and then iodine. Since bromine is higher on the periodic table, iodine cannot replace the bromine. All right, so another way of thinking about it is the higher the halogen is on the periodic table, it has to be in the compound. Now, we don't always talk about them being in a compound since our halogens are soluble in water with a few exceptions. So sometimes when we write it, we take out the group 1 or we take out the ionic or the metal atom altogether. So here we have iodine with a negative charge, so that tells you that that was originally in a compound. And then you have the bromine diatomic. So the bromine will replace the iodine because it's higher on the periodic table. So it would form Br minus, and then you would have I2 by itself. So again, you're just switching partners. We would have to balance that to be correct. So all halogens form insoluble salts with silver, lead 2, and mercury 1. So we could not do a reaction like number 3 if the metal it was with was silver, lead 2, or mercury 1. And that is something that we can actually use to help pull those ions out of solution if we were trying to separate out things.